So the first thing that we're going to do is when you look at this graph, we'll start with the one on the left. Okay, it asks you to look at it in terms of the sine function. Okay, we can see that this one has been shifted horizontally, correct? Otherwise, we would have had our intercept, the midline would have passed through this y-axis. And so the fact that we can see that it got shifted here. And so what you can do, the fact that it says that it's a sine graph means let's find where the midline is. So as far as finding the full equation here, okay, what I would first do is based on the graph, I would find my amplitude and my midline. So what I would do is I would set it up in this way. So here and here, just I mark these on my y-axis. Those are my max and mins. Okay, so when I look here, what's the total distance between 10 and negative 2? 12. So if I cut that in half, what would that be? Half the distance between these two is 6. So what I'm going to do is I'm going to have an amplitude of 6. Right? So if I go up 6 or I go down 6, I'm going to get my midline. So my midline is at y equals 4. I can see that from my graph. And what I see here is that the distance from here to here is 6, or here to here, 6. Okay, so right now I know two parts of my function. It asked me to use f of x equals, so I'm going to set this up as f of x equals. And I'm going to have my amplitude in front is 6. Now, it could be a positive 6, could be a minus 6. So I'm going to leave some room in front. I might have to put a negative there. And then I'm going to get my sine function, so sine of. I'm going to have some possible shifting inside, but I do know my outside is going to be this vertical shift, the midline, and it moved up 4. So I know this much of it is set up. Okay. So the next thing that I need to do is figure out what goes inside here, and when I determine what goes inside here, I'll also be able to see, is it going to be reflected or not? Okay? And so the way I can determine what goes inside here is I can use the period. I can identify what is the period of this function. Okay? So the way that I would set this up, or the way that I would look to calculate this, would be I'm looking for some values here that I can see. Right here I can identify. Because I'm dealing with a sine function and I know it, I'm going to look at the midline where I have intersections. So here's where one of my sine periods begins, right on the midline, starting to go up. And if I look down, I see that that corresponds directly with negative pi over 3. So when I complete one full rotation of this period, I wind up right here. And again, I go down, and I see that that's 5 pi over 3. So if I wanted to find the period is going to be the distance between those. So again, it's the absolute value of the difference of their coordinates. So negative pi over 3 minus 5 pi over 3. And what does that give me? Negative 6 pi over 3, which is 2 pi. Okay? So what I see here is my period's 2 pi. So there's no multiplier in front, correct, of my x. If I had a multiplier in front of my x, it would be something other than 2 pi. And so I know that my x has to be just x as it sits. And so what I can now do is see, how did this graph shift? Okay? And so when I look, my graph, this point right here would have started at my y-axis, but it got shifted to the left how many units? Pi over 3, right? This point got shifted over here, pi over 3 to the left. And so how do we represent a shift to the left when we're talking about horizontal shifts inside functions? X minus a minus pi over 3, so it becomes plus pi over 3. So this right here is the function that designates this graph. Okay, now, here's the thing with these periodic functions, these functions that repeat the same pattern, is this is not the only answer that you could write. Okay, because what if instead of seeing this as being shifted to the left, pi over 3, what if you saw it instead being shifted from here all the way to here? So if you saw it being shifted to the right, everything else would still stay the same. We'd still have here f of x is equal to, I have my 6, sine of x plus 4. Okay, but if I looked at this as being shifted over to the right, so now as it moves through, what would my horizontal shift be? Minus 2 pi over 3. And now notice, though, if I shifted in this direction, did my graph have the general form of a sine? Did it go up, like the midline maximum, midline minimum? No, instead it went down first, right? If I shifted to the right. So if I'm going to use this as my shift, then I have to account for this as a negative because it got reflected. So the other possible way that you could have entered that answer would have been negative 6 sine of x minus 2 pi over 3, all plus 4. And those are equivalent functions. And they give you the same thing. Okay, I want you to try and see if you can follow that same process, okay, of putting all that together. See if you can do the same thing over here with, again, in this case, the cosine function. You could always take into consideration the shift that would give you the positive part of that sine or that cosine function. Okay? So if you would like working with positive signs, you should shift to the left here. If you like working with negative signs, or if you don't care, then you can do either one. But if you have a preference, you can purposely look for the right transformation based on keeping it a positive function or a negative function. All right, so when I set this up, the way I'm going to approach it is I'm going to mark off my extreme points, max and min. I'm going to find out what that total distance is. So from 2 to negative 8 is 10. So half of that is my amplitude. So I know my amplitude is going to be 5. So if I go up 5 or down 5, I'm going to wind up in the same place, which is my midline. So y equals, I see that my midline is negative 3, and that's based on this amplitude of 5. So I can fill out that portion of my function right now. F of x is equal to my amplitude 5. Again, notice I left a space in case I wanted to use the negative cosine. I'm going to leave room for any kind of phase shift or horizontal shifting. And then because my midline is at negative 3, that's going to be my last piece. Okay, once I have this set up, I can then go in and find my period. So here what I'm going to do is I'm going to use this maximum. Again, because it's a cosine, I'm looking for my maximums. The period completes and ends right here. So if I look down, it goes from negative pi over 2 to 3 pi over 2. So my total period is negative pi over 2 minus 3 pi over 2. Again, it's that total distance, which is negative 4 pi over 2, or once again 2 pi. Okay, so what here, even though we're not doing any kind of, we're not compressing this graph, I still wanted to talk through the process you would use to find that. So I have my total period from here to here is 2 pi. And so when I look at my shift that's occurring, normally my graph would have started right here, up here. It gets shifted to the left, how many? Okay, so again, my period is 2 pi, so there's no multiplier in front of my x. Minus a negative 2 pi becomes plus, minus a negative pi over 2 becomes plus pi over 2. And so this right here would be my function. Now, again, let me show you some alternate values, because you could have shifted this to the right. We could have used this point to this point. If we use those 2 points as our period of 2 pi, what we would get for our function would be 5 cosine of x, my minus 3. That all stays the same. But here I would have shifted it minus pi over 2. But instead of this starting out as a maximum, it started as a minimum. So what do I need to put in front of my function? a negative if that was the case. So these two equations or functions that I've written here, those are equivalent. There are two different ways to write the function for that graph. Okay? And the system will accept any correct answer. Okay? So you could have also, if you looked here, you could have also taken from this point to this point. If I had set it up using those points, then what function would I use here? That is the sine. So I could have also used, again, everything the same. F of x is equal to 5 times now. I could have used the sine of x. The minus 3 stays. Here my shift would have been pi units to the left. So x minus a negative becomes plus pi. And this is a positive sign. So I could have also written my answer in this form.